Antibiotic resistance is one of the greatest threats to global health. But what if artificial intelligence and phage therapy could be combined to help fight it? This is especially important within the global context of antibiotic resistance. As antibiotics become more limited and less effective, phage therapy will be the counterpart to succeed them. However, phage therapy currently involves lots of initial wet lab testing, which leads to high times and high costs, which make it extremely inefficient and less viable for those who have limited financial accessibility. The innovation that fixes this, PhageAI, a web app combining artificial intelligence with phage therapy to greatly accelerate phage therapy discovery. This web app takes genomic data from the NCBI and trains it using a light GBM model to then get results which predict which phages are most compatible and most effective for different bacterial species. Let me walk you through how we can do this on the website. Over here is the home page, created with a combination of TypeScript and Next.js. It's both simple and easy to use, so that our consumers, such as starting biotech startups, or hospitals, or doctors, or independent clients as well, could use this to do their predictions. First, we'll start off by just clicking Start Prediction here. And now that we come down here, people can either upload their own genomic data or select a bacterial strain here. For the purpose of this demo, I'll select Staph aureus, a multi-drug resistance bacteria that causes hundreds of thousands of deaths per year. And over here pops up specific strain details. Now we'll run it. What it's currently doing is it's running our light GBM trained model on the NCBI genomic data and pre-curated interaction matrices of phages and hosts. Now we have our results. We have the species, GC content, genome size, and predictions for 88 phages. Over here we have a bar graph with the top phages that had the highest compatibility and confidence scores. Over here we have the compatibility score range. What this shows is the host species diversity and how it can respond to phages. And now here we have different features and how they contributed to our analysis. And over here we have the ranked phage predictions going in deeper detail upon the compatibility and confidence and giving a quantitative as well as a qualitative metric to measure the success of these phages against Staph aureus. Now, what does this do? Well, it allows scientists to completely skip initial wet lab testing, which is both high cost and high time, and it cuts down on both of these, making phage therapy extremely viable and allowing for scientists to select the two phages that they might want to create a cocktail with, which would greatly reduce the chances of a bacteria developing resistance to these phages and greatly increase the effectiveness of these phages against these bacteria. By combining phage therapy and artificial intelligence, we're helping the world fight antibiotic resistance one phage at a time.